Hi, Nathan. Thanks for your question. So it says 2 ammonia plus copper 2 oxide yields 3 copper metals, a nitrogen gas, and 3 water molecules. And it says in the above equation, how many grams of nitrogen can be made when 127 grams of copper 2 oxide are consumed? And then you have the reaction here again, and it gives us the molar masses. So I'm just going to switch over here to the camera view. So I've just rewritten the equation right here. And effectively, what we're told is we have 127 grams of this copper 2 oxide compound, and we want to know how many grams of this nitrogen compound that we can use. And I'm going to use the molar masses from that table that's provided so that we get the right answer for your computer system here. So let's take a look at how we might approach this problem. Well, we need to convert from grams of one compound to grams of another. Unfortunately, there's no good way to do that. So we have to convert from grams of this compound to moles of this compound, because there's a good way to convert from moles of this compound to moles of this compound. And once we have moles of nitrogen, we can convert it back to grams. And what we're essentially doing is what's called stoichiometry. So in this case, we want to go from grams of CuO, and what I'm writing now is what I call a plan of attack. So we're going to start with this. We're going to convert it to moles of CuO. To convert from grams to moles or moles to grams, we use a molar mass. Then we're going to convert it to moles of nitrogen, because the balanced chemical equation provides a good way to convert from moles of one compound to moles of a different compound. And then finally, we're going to convert it to grams of nitrogen. So because the question asks us for how many grams of nitrogen we can make. So starting with 127 grams of CuO, we're going to convert to moles by using the molar mass. Using the table below, we're going to add together the molar mass of Cu and the molar mass of O, and we're going to get 79.5 grams of CuO on the bottom and 1 mole of CuO on the top. Note that we want grams of CuO to cancel, so we need to keep it on the bottom. We keep moles on the top because that's what we're looking for. Now we want to convert to moles of nitrogen. Well, to convert from moles of one thing to moles of another, that's what the balanced chemical equation is useful for. So if we look here, we have 3 moles of CuO. We want to get rid of CuO, so we put 3 moles of CuO on the bottom. And we want to find nitrogen, so we put 1 mole of N2 on the top. Then finally, we want to convert to grams of nitrogen. So again, from grams to moles or moles to grams, we use the molar mass. But in this case, we want to put the 1 mole of nitrogen on the bottom. And if we use the table at the bottom of your question, we find that 1 mole of nitrogen is 28 grams of nitrogen. Notice that nitrogen is diatomic, so it's not 14. We need to put in 28. To solve this, we multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, repeat to the end. And when you get to the end, you get 14.9 grams of nitrogen. Note, you could also multiply all the tops and then divide by the bottoms one at a time. I hope that you found this video helpful.